There's no end to unveil the mysteries of space. Hello to all. My name is Wang Yaping. I'm very glad to see all of you again. And today is our second class. So I invite the two other lecturers to say hi to you. Hello class, my name is Gang. My role today, I will be the cameraman. Hello folks, my name is Guangfu. I'm very glad to be part of the second lecture in space. In the previous class, we had a room tour here in China's space station and show you a lot of very interesting experiments, a lot of really interesting scientific phenomena. I don't know whether you had a lot of studies after class, but I heard that a lot of students actually quite interested in the fluid phenomenon in the microgravity. And the last class, actually, I made a blue planet. And today, let me show you another miracle. Last month, we had Beijing 2022 Winter Olympic and Paralympic Games, and we cheer for the great performance made by the athletes. And here, looking at a space station, it's the same in all seasons. But here, I would like to echo the ice and snow. So here I would like to show you. It's very easy to do this, and you also can get in your daily life, and you just get the acid stearic or the white vinegar plus the baking soda, and you can get this solution. And this is what we call super saturated solution, and that's the sodium acetate. Let me squirt a ball of solution. All right. It seems like already crystallized. It doesn't matter. Let me change to our plan B. It's another bag of this supersaturated solution. Let me try again. So let's squirt a ball of fluid. It seems like the straw or the opening of the straw is already saturated. Let's do it again. Let me squirt another ball. All right, here we go. We got a ball, and let me get this. Let's see this. Can you see this? It starts to change, right? Right now is the crystallization of the supersaturated liquid. It seems like the ice ball. Do you know the reason behind? Why? Because that's a very high the solubility of the solution in water. So when we have a little material to change, that's the metastable status, and then it will be very soon become this crystallization status, and also we will see that exothermic situation. So that's why I also can feel a little bit heat from it. So it can also be a heated ball. And of course, you do this on the ground. Should be in a container, but here you see there is no container. That is why we can flow it everywhere. So when it's crystallized, then it's like this. So in microgravity environment, we know very well about that, the surface tension, and we can get a very crystal clear ball of water. Let me give you another experiment to show you more experiments about that surface tension. Let's see what we have. We have a two transparent board, and Mr. Ye have a bottle of drinking water. And also I believe our students in the classroom also have a similar tools right on the table. So let's do it together. So first let's squirt 2 balls of water on these 2 board or these 2 pad. All right. Let's move these 2 balls facing each other. And at the very beginning, they're not really friendly each other. And right now you can see they get along with each other. And let's see what happens. If we move a little bit, you could see that because of surface tension driven phenomena, actually these 2 balls of water connected like a bridge, connecting from one side to the other side. So on Earth, the surface tension is a very subtle force, so sometimes this is really difficult to do on Earth, but in space you could see this is comparatively very easy to do so. Alright, that's the liquid bridge. And then we to think about whether we can have a elongated or longer one, a longer liquid bridge. So this is the question to you. If you have the answers, email back to us. You could see and tell there is a huge difference between the Earth and space. And also last time, students also have a quite a big interest in the buoyancy experiments. And this time, let me show you more experiments to talk about weightlessness.
Take a look. So in the bottle, actually, I feel like 2 types of liquid. One is the drinking water and also the oil. Actually, the density of water is heavier than the oil. So on the ground, on the earth, so if you mix these 2 liquids together and then the oil will flow above the water. Please join me and mix these 2 liquids to see what happened, to see whether there are any differences for the mix of the water and oil. Just shake. I can see oil and water are separated on the ground, but in the space station, it's quite different. The water is still mixed with the oil. For you guys, you will see there's a complete separation of the water and the oil. But in the space station, now you could see these 2 are still together. Now I would like to ask a question. What should I do to separate the water and oil? Please raise your hand if you have any ideas. Good afternoon, Ms. Wang. So before the lecture, actually, we just had some experiment with our teachers here. So at the beginning, we are trying to shake the bottle, and then we could see the water will create sediment. So maybe you could shake the bottle in order to separate the water and oil. Thank you for your answer. Well said. Yes, indeed, even though we are in the microgravity environment, we are not able to separate the water and oil. However, the properties of the water and oil did not change. As we all know that the density of the water and the oil is different, maybe we would like to use the centrifugal force to separate these two liquids. So now I will serve as the centrifugal machine. Now we are trying to rotate this bottle. So I would like to ask if we want to rotate this faster, maybe we need stronger force to rotate the bottle. Now you can see right now Mr. Ye is shaking and rotating the bottle as the density of the water is actually higher than the oil. So with the rotation, I believe there will be a separation of the water and the oil. Please take a look. Now we are able to separate the water and oil with fast rotation. Actually, in the space station, we do have some centrifugal machine. So in some of the experimental cabin, we do have the centrifugal machine. So we will collect some of the samples and also to make a separation, for example, the blood samples, urine samples. So actually, for some of the high-tech equipments, they are using very simple laws to conduct the experiment. Just now we have demonstrated 3 experiments. I believe you are understanding more about the liquids in the space station. So actually in the microgravity environment, it gave us a lot of opportunities to learn more about the physics and more laws. Now I would like to verify another law, the Newton's first law. Please take a look. What is that? So this is very popular Bing Dun Dun. So here I would like to drop Bing Dun Dun. Let's see what happened. Actually on the ground, in the earth, if I let my hands go and then it will fall. But what happened in the space? Now, I would like to throw Bing Dun Dun. So you could see it did not fall. It conducted a linear motion. Alright. I would like to throw it back. So actually, once again, it is doing the linear motion at a constant speed. So actually, this is not in line with the first law of Newton. So right now, the space station is rotating around the Earth. So from your perspective, do you think Bing Dun Dun is still doing the linear motion? This is your homework. So just now I have demonstrated a lot of experiments. I think it looks quite different when we conduct these experiments in the microgravity environment. So the reason we built the space station is because we want to make good use of the environment and conduct more scientific research. So maybe you want to know how scientists work in such a condition. So Mr. Ye will show you more about this. Good afternoon, dear
我
students.
们核心舱的前段
So in the
是
core
科
module
学
at the
实验
front
区，
end, we have a
为了能够
laboratory
在太空中
section
开展科学
in
实
order
验，
to conduct
航天
scientific
技术的
research
专
in
家
space.
和科学家一
Some
起
of the
把实
scientists
验室
and
搬到了太
experts,
空。
they actually build up the
在上一
laboratory
次
in
的
space.
天宫课堂中，
Last time
我给
in
大家
our
展示了
class,
人体医学实验柜所开
I
展的
show you
星际细
some
胞
of
实验。
the
那么这一次呢，
experiments
我要给大家介绍两个新的
to
实验柜。
understand some of the
第一
cardio
个是在我
movements.
右手边的这个高微重力科
So
学实验
here
柜。
I would like to show you two more equipments. So this is the high microgravity
更高亮度
cabin.
的这么一个微重力
So in this place, it will provide an even stronger microgravity environment.
空间站不已经是
I
微重力环
believe
境了吗？
all of you are quite curious because in the space station, it is already in a
到底
microgravity
是什么样的
environment.
实验
Why we want
需
to
要
build
更
this
高的微重力水平？
another cabin to fulfill the needs
高
of
微重
high
力对物理学的
microgravity
研究
environments?
非常重要。
Actually, for the high microgravity environment, it is very important for us to do some research in physics.
比如说，在高微重
It
力
is
环境
more
下，科学家
precise
用冷原子
for
干
our
涉仪
research.
对原子进行加速度测量
For
对
example,
可
we
以对
could
爱因斯
analyze
坦
some of
广
the
义相对
cold
论中的等效
atoms,
原理进行高精度的检验。
and also we can conduct a lot of high precision experiments. So all of these are
说到这
basic
儿，
research
同
in
学们一定
physics.
会好奇，这么有用的高微重力，在空间
So
站
you may
又是怎么
be
实现的呢？
curious that even
好，
though
下
this
面
is
我们
quite
就一起来
useful,
探究一下。
how we
首
build
先，
this
请
high
亚平老师
microgravity.
打开实验柜门，给
cabin
大家介绍一下吧。
So right now, I would like to invite Miss Wang to open the door of the cabin so
在
you
这
could
个
learn
有
more
黑
about
色
this
点状矩阵的
apparatus.
柜门后面有一个悬浮实验台。正在
So here
打
we
开
have a operation platform. Now I would like to open this door.
这就是我们的悬浮实验台，
So this is the operation platform.
内进行实验。
So you could actually do the experiment inside of the cabin or outside of
实
the
验台
cabin.
有内外两层，
So we
外
have
层
two
采
layers.
用喷气控制，
In the
内
outer
层
layer,
采用磁悬浮技术控制。
we are able to
喷气加
conduct
磁
some
悬
of
浮
the
不能
suspensions
动量
experiments
抵消空气扰动、平台振动所带
by
来的
having the
影响，使实验台内
magnetic
的微重力
suspension.
水
It could
平
actually
舱内
reduce the
要提高
resistance
100
in
到
the air.
1000倍。
This will help us to improve the level of the microgravity in the cabin.
前段时间，我们就和地面的科学家一起配合，开展了一次柜体外的
In the
悬浮实验。
past, we actually done a lot of the magnetic suspension experiments with the scientists on the Earth.
好，同学们看，现在实验开始了。
Please take a look.
我慢
The
慢的
experiment
将悬浮
started.
实验台
So
从
now
柜
you
体
could
中
see
取出，
I removed
然后呢，
this
根据
operation
地面的指
platform
令，
from the
将实
cabin.
验台
In
放置在
accordance
一个
with
舒适的
the
位置
ground
并稳
control
定好。
center, I try to stabilize
好，
this
现在
operation
我
platform.
轻轻的给这个实验台施加一点力，同学们注意看会发生什么。
Now let's see what happened.
哎，同学们看到了吗？这个实
Do you
验
see
台
it?
虽然受到我的干扰，但是呢，
So,
它还是能够
even
做
though
喷气，逐渐的回到了原位。
This
同学们想一
operation
想，
is interrupted
这
by
个
my
实验台
movement, but still
它
it
是怎
could
么
still
知道要
work.
回到哪里的呢？
But you may
好，
wonder
大家看，
why this
奥秘啊，
experimental
就在这
cabin
里，
knows where to go.
在这个柜门上有一个黑色的点状矩阵，
In the
叫
door,
做法标。
you could see
相
there
当于
is
是
a
一个参照物。
matrix. So this is
而这
actually
个
a
悬浮实验台的
benchmark
后面
for
有
this
2台相机，
operation
通过相机
platform.
来
And
观测
behind the
这个法
door,
标，
also it
它
has
就可以
like
获
two
得相
cameras.
对于柜体的位置和姿态的。
So for all of these devices, it
实
will
验台
help
被推
to
动之后，
locate
它相
this
对法标会产
experimental
生偏离，
cabin.
也就产生位移。那么
Even
实验
though I
台
moved the
检
cabin
测
a little bit,
产生偏离之后呢，它会自行的
but
启
for
动
all of these
喷气
equipments,
来校正
it
这
could
个偏离。
actually identified
然后慢慢
the
地回到了
location
原
for
来的
the
位置。
cabin, and then to make adjustments so that the cabin can move
朋友们，
back
这样明
to
白了
where
吗？
it was.
就是这个双层的悬浮实验台为科学家提供了开展更
So
精
for
密
this
科
double
学实
layer
验的高
magnetic
维动力环境，
suspension
是不是很神奇呢？
machine, it will help the
提到悬
scientists
浮啊，
to do more
我们的
research.
舱里还有一个悬浮高手，他就在我们的
Speaking
头
of
顶
the
上，大家跟我
suspension
一起来看看。
technology, actually we have another device.
大家看，这个就是我要给大家介绍的另外一个
So this
更
is
炫酷的一个实验柜了，
another
它叫
experimental
无容
cabin.
器材料实验柜。
This is what we call
这
the
里是无容器材料
container-free
实验柜的一个核心组
experiment
件。
cabin.
在
These
这个
are the
盖板
key
的里面
parts.
有一个实验的腔体，在这个实验腔体里，实验样品啊可以在微重
So
力
in
环境
this
下
area,
通过静电场，
we are able to put some of the sample in the microgravity
从
environment.
而避免与整个实验腔体内表面的一个接触。所以
So
我们叫
because
它
of
无容
this
器。
technology, some of the
这样一
key
来就
parts are
避免
able
了
to
容
suspend
器
in
材料
this
本身对样
microgravity
品的影
environment,
响，
and
我
it
们
will
就可
not
以
hit the
准确地
surface
测量
of
样
the
品的作用物理性质了。
experiment cabin.
同学们回想一下，这个是不是和刚才亚平老师给大家展示的
So just
太
now,
空医
Miss
学实
Wang
验有点相
has
似呢？
done some of the experiment about the
是的，他
crystallization
们
in
都是利
space.
用空间站的微
Yes,
重力
indeed.
环境实
We
现了
take
无容器状态。
the advantage of the microgravity in space to achieve this
那前期呢，我
container-free
们就在这
situation.
个实验柜里开
And
展了
also we
倒计
have
时的实验，
conducted the basic research
只有
in
2
these
到
many
3毫米。
cabinets,
到
and
人
also
来下
as
指示
conducted in this a very small
好，
tiny
从切换
equipment. Look at this video clip.
实验开始了。
So
首先，
this
第
is
一
the
个，将小
experiment.
球
You
从
could
释
see
放
that
机
a
构中
very
取
little
出，
ball. First we
并
got the
推
ball
出小
out. So you
由
could
于受
see
到静电场的不控制，小球可以稳稳地悬浮在中间。
that right now is under the suspension control, and we right now heated the
发
ball.
生什么样的
Let's
变化？
see what's
现
gonna
在
change.
小球已经被加热到了2000
So
度，
right now it's
融化
heated to
并开始
2000
进行
degrees
表面张
Celsius,
力和
and
粘度
also
技
can
术的无量
conduct
测
the
量了。
many different measurement of a physical
停止加热，小球开始
the
迅速地
numbers,
降温，
and we
将
could
气
see
按下来了。
right now we cooled it
小
down.
球在降温的过程当中，刹那发出了亮光，这叫再推展。有兴趣的同学们可以进一步研究为什么会发
So
生
you
再
could
推展。
see that there's a quite
小球
blinking
凝固成固体
happened
之后，
during the
被
cooling
收到了
system.
样
So
品盒
if
中。
you're interested, you could check why that situation happened, and then we will bring all these experiments and results back to the ground
去年9
for
月，
scientists to conduct
第
following
一
up
批样品
experiment.
已经被
Last
神舟12号
September,
乘组航天
Shenzhou
员
12
带回到了地球，并
crews
交给
already
了科学家
brought
们。
the first
现在
round
正在
of the
进
result
行
of
着
the
研究和
experiments
分
back
析。
to the ground,
我们也
ready
期待
right
他们
now
能够早日
given
取得
to the
研究
a
成果。
scientist. So we're waiting for more outcomes
好，同学们，
from the scientist.
科学实验是助力科学研究的重要手段。
Experiments play a key
科学
role
实验柜
to
是我们
making
在空间站
contributions to the
开展科学
progress
实验的一个主要设
of
施。
science, and here the
等到问
space
天
is
实验
one
场
of the
和
key
梦天实验
location
场
to
发射
conduct
入
all
伍
these
之后，
experiments.
我们将会
After
增
we
加
receive
更
the
多的实验
Wentian
柜
and the
开
Mengtian
展更多
experimental
领域的科学实验项目。
ships, we will conduct
到那
more
个时候，国外科学
experiments.
家都
I
可以
believe
通过
later
实验
on,
柜来开展
the
研究。
Chinese and Western
而我们中
astronauts
国的
can
空间站
conduct
将
more
成为
experiments
全人
here,
类的
and
一个
we
太
hope
空实验平
that
台。
we can bring the benefits
朋友
to
们，
all
我
human
们也
beings
热切地
around
期
the
待着
world.
你们能够
And for
提出
all the
你
students
自己
here, I'm
的
also
科学实
waiting
验
for
设想。
you to have
说不定
your
下一次
ideas
我们在
about the
太空中
next
展示的
experiments in
就是
space,
你的
and
实验
maybe
项目了。
next time you will see your idea will be carried out here as a one of the experiments in space. So waiting for you,
参与进来吧。
think big, push the boundary.
好，今天我们主要的授课内容
All right,
就到这里了
that's。most of the
接下来呢，
lectures,
我们进入到课堂
and
提
then
问环
we
节。
come to the Q&A session.
不过首先我们要回答一下网友们提出的
Before
问题。
that, let's first look at some of the questions we received online, because after the first lecture, we received so many questions online, and we received all these questions by the Earth ground email system, and we select some of the questions, and here, let's try to answer them. So one question is, if you feel like the tears, so what's the shape of the tear? Is a drop of water or a stream of water? So what happened to your tears? It's a very interesting question, actually. We had a lot of exciting moments, and also we have tears, but unfortunately that's not really coming out. So it's not really coming out of our eyes as at the corner of the eye. I believe this is really hard to do on ground, but it's very easy to do in space. We can hold our tears. So another question is whether your skin can be improved. I believe that's a very good question, maybe from a lady. So that's a beauty question, and because there's no sunshine, and also the humidity and temperature is also constant. And we talk about under the microgravity situation, our body fluid also going up to our head, and also our skin also coming to my head as well. So for myself, I think that's my skin's getting better, and we also have the different beauty products prepared by our ground staff, so we can have our basic daily routine. But for toner, of course, you cannot pull it out. We have the equipment to squirt the toner out. And maybe let's give opportunity to ask questions from Beijing first.
我们首先请那位同学吧，对，倒数第3排，对。天然老师们好。
Hello to 3 lecturers. I'm very interested in the container-free cabinet. I believe it's really amazing. I would like to know what kind of materials can be conducted inside to do the experiments, and what kind of the role all these experiments play. Maybe I invite Mr. Ye to answer your question.
这个问题啊非常好。
That's a very good one. We talk about containerless cabinet, which means there is no touch or contamination happened to the material, and we also do not need to worry about that the stratification caused by gravity. So we can produce the new materials or the new turbine plate. I believe we also can have that the material produced here to learn more about the heating system in the early solar system. Another question from Beijing.
这一次我们请那位男同学吧。 对，15号桌的那位男同学。
老师们好。听说天宫
Thank you very much. Earth light Tiangong actually orbiting the Earth in 90 minutes. So what's the time sighting here? So you follow the Beijing time or GMT time? So what's your daily routine? Thank you.
好，这个问题请。
Maybe I invite Mr. Dai to answer your question. Alright, here at the CSS, yes, we orbit the Earth in every 90 minutes, which means in every 90 minutes we see one time sunset and one time sunrise. Inside the space station, we have Beijing time, we also have a world time. We also have a comparative flying time and also absolute flying time. Based on different mission, we follow different clock. Normally, let's say if we have Taikonauts station inside the CSS, then we follow Beijing clock. So which means right now our daily routine is follow the Beijing time. Thank you for your question.
Alright, now I would like to invite students from Tibet to ask the question. Please raise your question to our astronauts.
好，那就请我身边这位女同学来提问一下吧。
航天员老师，你们好。
Good afternoon.
就是我平时特别喜欢观察月相。
Actually, I always like to observe the lunar surface. So I would like to understand when you're staying in the space station, what's the difference of the moon? Does that look different? Any change of the surface of the lunar? And also, I understand that the operation speed of the space station is very fast. It will rotate about the Earth about 16 circles. So still, I want to understand, in your eyes, what's the difference of the moon? I would like to answer your question. So for the space station, it has a 400 kilometers away from the Earth. And however, for the Earth of the moon, it's quite distant. It's over 380,000 kilometers, and also this is the same distance from the space station and the moon. So from our perspective, the moon looks pretty much the same as we are in the Earth. But if we are looking at the moon from the space station, as we will not be influenced by the cloud and atmospheric layers. So if we look at the moon from the space station, the moon is more brighter and clear. Thank you for your question. Any questions from Tibet?
同学们，你们还有什么其他的问题吗？
Any more questions to
好，
ask
来，
the
请这位男
astronauts?
同学来提问一下吧。
航天员老师，你们好。
Good
我们所
afternoon.
处的拉萨位于海拔
So in
3650米。
Lhasa, we have at the elevation of 3,650 meters. So actually, the boiling point is actually lower, as we all know that if the altitude is too high, and then the freezing point will be low. So I would like to understand: are we able to boil the water in the space station? Are you able to drink the boiling water in the space station? Thank you.
好，这个问题我来回答吧。
I would like to answer your
这是一
question.
个非常好的问题啊。
Very
通
good
常我们
question.
所说的开水是指温度达到
When we talk about the boiling water, it's actually the water at the temperature of 100 Celsius degree. Actually, in Lhasa, we understand because of the altitude, so the boiling point will be reduced. But actually, inside of the cabin, because we are in the microgravity environment, we are not able to boil the water. So in general, the temperature is lower, and on the Earth, it is easy to boil the water, but in the microgravity environment, we don't have the buoyancy. We are not able to boil up the water because we don't have the impact of the convection. It is not easy to boil the water.
空间站的饮用水是经过特殊处理的。
So for all the water we drink, actually it is processed by special equipment. We could drink this water directly, or we could use the heating machine to heat up the water, but in the end, the water cannot be boiled.
新疆课堂的同学
Now I would like to turn to the classroom in Xinjiang. Any questions?
好的，同学们，你们有没有什么问题想要咨询我们的航天员老师呢？
Any questions to ask the
请
astronauts?
这位女同学问一问。
航天员老师您好，
Good
我
afternoon.
刚才看到你们展
So
示的
just
科
now,
学实验柜啊，
I
觉
saw
得
the
非常厉害。
experiment, especially some of the experimental cabin.
以后我
I
的
think
果蝇也能送到天上
This
做
is
实验
quite
吗？
unique.
谢谢老师。
I would like to understand whether some of the object can be sent to
非常
the
高兴
space
看
to
到
do
你
the
喜欢生
experiment.
物学研究。
So I
在
believe
生
you're
物学
quite
呢，是我们空间
interesting
站
in
要未
the
来支持的一项
biological
重要
studies.
科学领域。
I think biological
在我们
studies
即
are
将
very
发射的
important for
空间
us.
站的问天舱里，就有支持动植物、非
So
生物研究
actually,
用的
in the
生命
Wentian
生态实验
laboratory,
机
actually
会。
we do have
我
a
们
lab
不仅欢迎
to
来
have
自
some
科学家们
studies
的实
about
验，
the
也
fruit
欢迎
fly.
同学们的奇思妙想。
And of course, we welcome
另外，
all
我
of
还要
your
告诉你的
ideas.
是，果蝇是生物
For
学
the
常
fruit
见的
fly,
实验对象，被大
it
量
is
地使
commonly
用在
seen in the
遗传学
research.
和发育生物学的研究当中。
So we could use
我们
all
的
of
科学
these
家也
creatures
计
to
划
do some
将来把果
biological
蝇带到空
studies.
间站里
And
进
in the
行
future,
研
we
究。
do have plan
所
to
以
bring
你
some
的
of
想
the
法和
fruit
科学家们
flies
是
into the
不谋而合
laboratory
的。
in the space. Actually, you think alike with the
好，
scientist.
我们新疆课堂的同学还可以继续提问。
Any more questions from Xinjiang?
好的，请问还有哪位同学想要提问？好，机会难得，我们把机会交给这位男生。
航天员老师好，
Good
我
afternoon.
的问题是，
My question
天宫
is,
在飞行时会不会受到阻力？是
so
不是只
when
要达
the
到所需的速
space
度，
station is
就可以
working,
不再
does
施加
that have
阻力？
been impacted
速
by
度
the
是否保持不
resistance?
变呢？
Will
谢
it
谢老师。
maintain at a constant speed? Thank you.
这个问题还是由我来回答吧。
All right, I will take your question. Yes, we may be
要施加动
impacted
力，
by
因
the
为虽然我们所
resistance
处的
force,
高度
and we do
虽
need
然
some power,
但是我们的虽然这个高度比较高，但是仍然还是有阻力的。
even though we are
所以
quite
会
high.
导致我
However,
们
we
的
still will
运
run
行速
into
度
some
降低，
resistance,
使我们的
so
轨道
this will
也会降
actually
低。
have some
所以为了
impact
维持
for
我
our
们
speed.
的运行轨道，我们必须要在
In order
需要
to
的
keep
时候
ourselves
施加
in
动力。
the orbit, we need to
好，
have some
那接
power
下来呢，我们
to
请
propel
北
the
京
space
课堂
station.
的同学来提问
Now
吧。
I would like to turn back
同学们
to the
还有问
classroom
题
in Beijing for more questions.
好，机会又来了。这一次呢，我们把机会给这边的同学吧，这边对。
航天员老师好。
Good
空间
afternoon.
站的环境和地面
In the
完全
space
不
station,
同。
I believe the
非重
environment
力
is、
高
completely
辐射等
different
情况的存在，让
because
我
it is
特别想了解
microgravity
老师们在空间站都做过哪些有意思的实验，每天
and
花多长
also
时
I
间进
believe
行
there's
实
a
验
high
呢？
radiation.
我
I would
们
like
天
to
地对话
understand
这么方便
what
快捷，那
experiments
么地
have you
面可
done
以
in the
直接操
space
作得到
station.
实验数据吗？谢
So
谢老师。
as we know that it is quite advanced for the space station, can we operate some of the operation and the
好，
experiments
这个问题
and then we
呢，
can receive the
请叶老师
results
来
on
给
the
你回答
ground?
吧。
I would like to
好的。
invite Mr. Ye to answer your question.
除了我们刚才展示的
So
实验
just
柜
now we
相关
have
实验之外，
demonstrated some of
我
the
们利用
experiment
空间站的
cabin
一个特殊环境
and
我们还开
in
展了
the
有
space station
医学、
by using
物理学、
the
材料
special
学、
environment.
心理学，还有生命科学
We
等多
conduct
种学科的研究。
many other research,
此
for
外，我们
example,
还对
in
一
medical
些先进
service,
的检测技术中医药等
mental
传统的医
mental
学
disease,
开
and
展
also
空
we
间
are
利
also
用研
doing
究。
some of the
这些都
research
有助于我
into
们
the
探究
traditional
空间
Chinese
环境
medicine.
中人的各种变化。
So by
发展性的是
happens
非常
to
繁忙的。
human beings,
除
and
了
actually
开
we're
展
quite
各
busy
项
every
实验
day
之
in
外呢，
conducting
我们
different
还要开展
experiments.
日常的维护、巡检、
And except for doing the experiments, we also need to have routine inspections and maintenance for the space station. As for your last question, I think right now it's quite convenient for the dialogue between the space and the ground. So when we are conducting the experiment, we're able to work with the scientists on the Earth. We are able to send out some of the results back to the Earth. One more question.
这次我们请这位同学吧，把机会给边上的同学。对，16号桌。
彭天元老师您好。
Hello to lecturers in space. I want to become a scientist. Previously, I only know that scientists need to do experiments on the ground, but right now, surprisingly, I know that the scientists also can do experiments in space. Then my question is that, do you think I have the possibility to become a scientist to do experiments in space?
这位同学有非常远大的理想抱负。
I believe that's a really good dream. So, thumbs up for you. So, the purpose of establishing China's space station is to conduct a whole bunch of experiments, and we talk about the all these experiments actually open to all the scientists and astronauts around the world, and also welcome more astronauts and scientists to conduct their experiments in space here in China's space station. I also welcome our students in the future to do the experiments by yourself in space, but right now you also can give us your idea and also can do a remote operation of your experiments. So right now your job is to work out, have a strong body, and also to learn more and believe anything is possible. I believe our students still have more questions, but unfortunately that's the end of today's class. And thank you very much for our 3 lectures and waiting for you coming back home with a triumph.
谢谢老师和同学们。
Thank you, the students, and thank you, the faculties. And Wentian and Mengtian this year will also be launched. I believe I have an even stronger capability to conduct scientific experiments, and please stay tuned. We will have more classes from the space. You hold your future, folks. So to unveil the mystery of space, to make China also a strong country, a strong power in aerospace, and please to study harder and to achieve your dream with unremitting efforts. So flying to the space is always our dream, and we never give up exploring science. So keep up and also to study more science, and there are a lot of things waiting for you to explore, and here is your future home in space. See you next time. Bye for now.
再见。